name is Rain. I'm going to be the review of this page. Okay. First, I'd like to make a question for the reporter. How did you get to that equation, and how did you solve this with the two Bessel functions?
Sorry?
I don't remember the number of the slide. The function of the time of approach.
But I solved the Young-Laplace equation for to get the shape of the meniscus.
Could you show me the demonstration of this, please?
Okay, basically the modified Bessel function of the second kind is the Bessel function which I showed is a solution to this equation. The modified Bessel function of the second kind. If you take a look at my the original equation which was derived, you notice that the equation which I solved.
We don't have much time.
Oh, okay. Sorry. You notice that the equation is of the form of that I showed earlier.
Okay. Do you agree? Good point.
Yes.
Okay. Have you considered statistical phenomena? For example, a Brownian motion occurring with the pins?
No, I did not.
No. Okay. Do you agree with me?
Well, how can I agree if you consider it or not? I don't. He says he didn't consider it. I agree. He didn't.
Is it relevant?
I feel that it's not very relevant because the microscopic phenomenon.
Okay. Is it relevant?
Any kind of influence on this process would be relevant.
Okay. What's the importance of the nature of the particles which are floating? For example, if they are hydrophilic or hydrophobic?
The hydrophilic or hydrophobic will affect the force balance and thus affect the direction of the meniscus and thus affect the nature of the attractive and repulsive force. Yeah, but in my experiments, I feel that the most important part is to elucidate the mechanism, and therefore I measured that part empirically.
Okay. What's the importance of the angles?
The importance of the angles. Okay, if the meniscus makes a greater angle, rather than a smaller angle, then the force would be greater here due to the fact that the gravitational potential energy gradient is greater.
Okay. And if you have this case of meniscus, what happens?
Oh, they attract.
Okay, why?
They attract because now the buoyant, as I said earlier in my presentation, now the buoyant, if their meniscus is downwards, then their buoyant potential energy would be dominant, and therefore, if you consider them separately, this particle would tend to want to float upwards because the buoyant potential. Yeah.
Do you agree?
Yes, if you. Yeah.
Okay. That's all.
Okay, thanks. So, 2 minutes of preparation.
Okay, I'm going to do the presentation of the review of the problem 7, drawing pins. Okay. First, the presentation scenario. We're going to talk about the theory, then the experiments, and the conclusion. Okay, the reporter. First, I'm going to talk about the positive points. It was a pretty good presentation. He made some force diagrams, and it makes the presentation very didactic. He made a good energetical approach for the problem. He mentioned the gradient pressure, made a good mathematical approach, and said about the behavior of the distancing function of the time. And made a good comparison between the theory and the experiment, and controlled very well the parameters of the experiment. But the negative points, he didn't consider the initial condition for the repulsion. In the slide 8, not shown a second object on the main scale, just consider the main scale with the recipient. In the slide 55 and 54, he didn't use both objects for the repulsion. Lack of experiments of the effect for two objects. Solving the Bessel functions with no analytical solutions. Didn't consider the parallax in the experiment setup, and didn't mention the chemical affinity of the fluid and between the fluid and the particles, and didn't mention the contact angle and the angles of the main scale in the presentation. And didn't talk about this case of attract. Okay, there is no curvature between the pins. And however, just reaction is still energetically favorable, we do not comply with their energetic approach. Okay, about the opponent, the positive points may ask some things about the shape of the particles, the geometry of them, said about the importance of the formation of the meniscus, talking about the influence of waves on the surface of the fluid, and said about the chemical affinity between the fluid and the particles. But the negative points didn't mention the viscosity, which was missing in the presentation of the reporter, made no questions about a little weird mathematical model, and made no questions about the experiments, which saw no much experiments, and did not mention the experimental errors, how you can see this in the presentation. And the general view of the discussion of the wave, they talk about the wave influence, which I agree is really important, and mention the repulsive case, which is the question of the problem. They talked about the shape of the particle, it's really important, and made a discussion of the meniscule formation, and mentioned the initial conditions of the particles. Thank you for your attention.
Thank you.